Alrighty, just one more thing to do, and then we'll get fully started. My chair broke the other day. I was leaning back in it, and I hacked it up. It's just a cheap IKEA chair, but there's a crack now on the front part here. So when I lean back, it splits. I think you can see that. Let me show you over here. So, splits there. I guess we can get rid of the starting soon. Text. Yeah, that's where it split. So I'm gonna reinforce it. And I've got a piece of aluminum that I'm just going to put behind that, just like that. This will be a very quick and dirty repair. And I plan to rivet it. So let me grab my rivet gun. Forgot to grab that. I guess the easier solution is just to grab a different chair, because it is getting a little bit bothersome. Every time I lean back in it, it feels super unstable. One day we'll get a better chair down here. One day. All right, got a big old pop rivet guy, and then assorted rivets. I do like the fairy lights back there. They look really nice. I wish they came just a little bit lower, but I like the number of bins that are there. So we'll adjust as necessary off stream. But I thought it'd be nice to get that done and get the kind of the stream preamble started. So rivets have different lengths for different thicknesses of material. And then they have different diameters. These are all 1/8 inch, but I have to pick the right length. So what I'll do first is drill for my 1/8 hole, although it may say they may be sized 1/8 and you need to drill larger. I'll see what the package says. There's the nice drill. We'll use the nice stuff. So let me see what it recommends. We can always just drill 1/8 and then drill that out larger. So it doesn't say. We'll try to 1/8 bit. If it's too big, we'll size up. We'll just do a quick audio check since we are officially started. Okay. Bring that back down. Alrighty, so let's try that 1/8 inch. And I will throw a trash can kind of under to catch some of the spillover. Let me see what camera one looks like here. Yeah, we'll zoom it into. Why not? Thank you very much, Amberlynn. Appreciate it. Okay, so I think what I'll do is line it up, drill through the plastic, which will mark the aluminum, and then I'll drill the aluminum separately. So that gave me a little mark. Now I can back this up with a little bit more force, since I'll have to push just a bit harder. And I can catch a little bit more of this. The debris. All right, this will be a good time to test the rivet. Yeah, fits well. I'm gonna just select a size that I think might work, and then drop that through. That should actually work. So you can always drill rivets out if they aren't the right size. If you drill the 1/8 again through the cap, you will separate the cap from the rest. Just tilt up a touch here. All right, so I've got a couple options. I could mark other holes, drill those, rivet it all up, or I could rivet this and then go from there and use it to hold everything on. I think with it just being in place, that's actually going to give me something to kind of key off of. So I'm going to go to this far side and drill through the plastic and mark the aluminum. And finish that off over the trash can. Okay, very good. Put this back together. Funnily enough, the holes don't line up, so that idea didn't work very well. So I will just rivet the one side. I'll need to find which chuck fits this. I think that might be the one. Dropping everything in the trash can. More than I wanted to. All right, can we get that back, please? Without too much fuss. There we go. There's a variety of styles of rivet guns. This is just the one that I had to hand, but it should work just fine for us. So essentially you open it up to release the grabbing mechanism, and then I'm going to apply just a little touch of tension just to hold it in place so that it doesn't drop anywhere. And then you want to make sure you seat this all the way, take up as much slack as you can, and then press the arms together. This will typically take a couple tries. So I do have another rivet tool that is one-handed. That would be a lot easier here. This is more of a heavy-duty one, but that worked just fine. So I'm gonna give up on the original plan, and I'm just gonna drill a new hole on this far side. There we go. And I think it's time to drop the jacket. All right, let's rivet this other side. Okay, line these up. Push it all together. Okay. So now we have 2 rivets across the back. On camera, like so. So that gives us some support here on the back. And I wonder that might just be enough on its own. Oh yeah. Oh yeah. That'll be good for now. I'll leave that as is. So yeah, quick little repair to make myself a little bit more comfortable here, because we'll probably be working from this chair just a little bit. All right, we'll need this later. So let's get started. Welcome to Fimorth on Twitch and Better Done Right on YouTube. We are going to be unboxing something to start, and then we'll play around with the laser and do some focus calibration to get the most performance out of the laser, the most sharpness, the most intensity. Let me make sure that I have this file transferred over that I was trying to get off of here. That I do. Actually double, triple check. I think this is even duplicate, but I want to double, triple check. Where's that one? Okay. Just need to give myself some more space on the hard drive. Okay, good. Oh, Windows. I think maybe this was the problem I was having, was it wasn't actually deleting the file, which is not cool at all. Let me open up the recycler. Oh, I don't need the recycling bin .png windows, if you can imagine that. we can empty the recycling bin. And then I wonder if we can drag this over. Nothing happens. Right click, click delete. Nothing happens. Nice. Good job, computer. Well, we have a little bit of free space, so we'll just rock and roll with this as we are and open up a box. We got something in. Pretty different than my typical stuff that I unbox. I unbox a lot of tech related things, stuff for the stream, stuff for the YouTube, things like that. But we're gonna take a look at something else today. Let me check on lurks very quickly. Do have one to add. Awesome. We've got 2 to add, so we'll add those. Okay, now we can get situated here. So I will bring you guys over to the overhead camera. Marie Aesthetic. Welcome in. Gonna lay down because your ankle is hurting, but you'll still be here not chatting. I appreciate that. Thank you so much. All right. Hopefully I can keep you company. And there we go. Let's click on all kinds of buttons there. So over here at the overhead table, I'll just update for what we achieved last time we were here. We were doing some tests trying to get our lamination process down without a laminator because I didn't want to buy one. And to cut it short, using an iron and towel did not work. So then I tried a heat gun, got marginally better results, but I also didn't get the bubbles out. So neither of those worked. So I think that's a bust. I think 9 tests in, you got to give up on a, for what I was trying to do, kind of a simple little test. So let me toss this over here, out of the way. And I guess ideally I would have a clean slate here. So maybe we leave the odd trinket to fill the frame, but we'll empty it of the rest of this, not junk, but scrap material. And put that down there. So we should now have almost. Now we should have a reasonably clean scene, which I think is what we have done. So we've got 2 boxes to look at. I guess we can look at this part of it because it's a little bit heavy. Do a little scene change here. Nope, wrong. There we go. So now we have the box. I would show you the sides, but that would give it away. So we will open this up. This arrived yesterday, and it's something I've been researching and looking at for a long time. So there's your reveal. These are adjustable dumbbells, which I'm very excited for. I can't imagine the struggle for the delivery person if they did not use a hand truck to get this to the door. There are 2 of these, 80 pounds a piece. Then again, my laser engraver was delivered by a guy and I did not see a hand truck. He just seemed to carry it, which is freaking ridiculous. So I'll try to drag this back kind of out of frame. Here, we'll swap frames there and drop this box off, hopefully. Good. And come right back with that. Did I hit the right button? I did. Yay me, go me. So obviously, these are pretty simple device, but there are a few details that I want to go through. The main thing, the obvious feature of these is that they are adjustable. So there's individual plates, excuse me, that drop in, and there is a large bolt on the side. These are the Eisenlink brand of dumbbells. They make a variety of different tools that share these weights, which is another component that I'm really, really excited about. So you can get a 60-pound version, or I should say, up to 60 pounds, or an 80-pound. I did get the 80-pound. I intend to use these for chest press. So the way these work, which if I can get this centered up without destroying my shoulders, the way these work is the screw on the side threads out enough until you can pull a plate to the side to release these pins, we'll call them. They're just Allen bolts that have been tightened in, and the flange to the head of this catches into the next plate. You'll notice the 2 outside plates are thinner. These are 2.5-pound plates, about 1 kilogram. And then there are 5-pound plates as well. And it's the 5-pound plates that have the recess to allow the head to nest in there. These claim to be 5-pound increment from 10 pounds to 80, I believe. Though if this plate is 2.5, then this must be less than that. So I don't know if the instructions will give me the exact weights. So it's adjustable by 5 pounds with a minimum of 10 and a maximum of 80. So these thicker plates are 2.5-pound plates. It looks as though with these thinner plates, perhaps you can adjust somewhere in between. I do have a scale nearby as to whether that is going to have the type of accuracy we would want. I do not know. And let me check if it takes the appropriate type of batteries. It does. So let me quickly trade these batteries out. Dana! Lurking, just folding some laundry. We should have a channel point redeem for lurkies. We should. absolutely. I don't know if you were here for my explainer on why there's 0 redeems and like all the commands and everything. Reason number 1 is that I'm very lazy. Reason number the second is I'm a little bit scared of it because I'm more of a hardware user. Like, I'd rather fix a problem with a camera than fix a problem on a computer. So reason 1 and reason 2 are silly reasons. Reason 3 is I don't want to get too into the weeds with it, have something break, and then not know what's wrong. So obviously the solution to that is just not put too many fancy things, gadgets and gizmos. But I know I'm not going to care about it all that much. So I know I'm likely to run into those issues. It's like if I set up a game server and we play on it for a month, I may not know how to run it 2 months later when we go back to the game, just because I tend to forget those things. They're just not, they don't stick in my brain the same. So off camera here, I probably should have changed cameras. I'm cleaning a scale off, so it's not as dirty as it was. I have fixed the overhead cam, so I've done something. Let me mute. But yeah, do your lurk. If you come back, we can chat more, but I'll let you do your thing. Okay, so why don't we see what we've got here? We'll let this calibrate. Let me make sure I've got a semi-decent angle here. Of course, this resets almost instantly. Okay. So the skinny plate is about 2.5 pounds times 2. The outer plate must be closer to 5. Yes. So you can add 10 pounds with the thick plate, or you can add 5 pounds with the thin plate. So it's the thin plates that are going to give you your half step, per se. I guess I would prefer a 2.5 pound step total, like roughly a 1 kilogram step, because that is a little bit more granular. But I think with rep ranges and everything, you could absolutely make it work for you. So why did I buy these in particular? There's so many other brands. The price of these compared to others is very reasonable. You can get a decent capacity, and the brand supports its ecosystem. So you can reuse these plates other places, which we'll take a look at later. Another component that I really like is this screw can be swapped out for a longer screw, and then you can carry even more weight per dumbbell. I don't think I will be needing that anytime soon. Another thing I like is the simplicity of this design. I didn't want something that had a handle that you'd lay into a dock and twist to select the weights. As convenient as that would be, I figured this would be tolerable. And I have a dead simple design. I literally just have metal plates with locking pins and a bolt to tighten it down. There's nothing to go wrong here. There's nothing really even to get damaged if you were to drop these for some reason. I think it's just dead simple, which I like. So, these are cheaper than Iron Master, which Iron Master has a similar concept, but the bolt is not threaded in the same way. It's smooth on maybe 70% of its surface, and then it just has some teeth. So I think it's like a quarter twist and then a pull out, and then you have to take the plates off the end. They do not have these slots that you see here. So I actually think this might be the superior product, but this is probably trying to be the cheap knockoff of the Iron Masters. But the Iron Masters, they've probably had to make their own system just so they can get whatever patents. But I love the simplicity of this. So why don't we look at the next component, the other box that was acquired. Dear God. Okay. This Widow box is also from Eisenlink. This, let's see how we want to extract this, is a kettlebell top handle. There we are. I think I'll just clean this off quickly. So this is quite simply a plate to fit the other plates and a screw, but with a kettlebell shaped handle, something that gives you a lot more flexibility to put these over your shoulder. So I'll just grab one of these 2.5 pound plates. Now, kind of an interesting thing that I just realized is because you're not having to duplicate the weight to keep the bell balanced, you can actually increase these in 2.5 pound increments. So you're not limited to 5 pounds with the kettlebell. So there's not much to see here, which is kind of the wonderful part of it, is such a simple, robust concept. You have a large steel tube handle that is very thickly welded onto a plate that gives you your basic weight. I don't even know that there were instructions in this box, like had been in the dumbbell box. I'm gonna say no. So why don't we, for thoroughness' sake, weigh this so we know our base weight. About 8.8 pounds with the bolts. And if I can get back before it resets, I cannot. It's absolute minimum weight, 6.2 pounds. And I guess you could also just work out with the bolt. Maybe you're really needing to recover from something major. But yeah, dead simple. It's weights with little keys on them. You can get longer bolts. You can get more weights. This brand also has a barbell, which is, I think it's maybe not a full width one, but you can get a barbell for this, and you can apply quite a few weights to it. So if you were doing, I guess, preacher curls or something of that nature. But yeah, there's a variety of accessories. So once you've invested in the plates, just like with a regular barbell set and Olympic weights, you can then transfer them over to other things. And the greatest thing is it's very, very quick and easy to remove these. You're not trying to pull off a whole bunch all at once. They come straight up. You have control over it. You can stack them and set them off to the side. The size of these is maybe a little bit bigger than I had imagined, but that's kind of the trade-off for having something affordable. They can't necessarily get the right balance of weight. I don't think I'm gonna be able to move this. Okay. Whatever thickness of steel this is, I don't know. It looks bigger than 1/4 inch, something between 1/4 and half. Approximately 8 millimeters. They wouldn't be able to get the affordability if they had to use a thicker plate, let's say. Then your weight ranges would be weird, but you could get a smaller plate. But then you'd run into other issues. So I'm sure they found their balance. It's a little bit bulky, but I think it's a good trade-off, and you do not, this will just hit larger dumbbell territory sooner because of its shape. And that's not necessarily a drawback. You can still maneuver this, twist your wrists, bend your wrist to kind of keep the edges off, or you could grab to one side. So yeah, that's the new thing in town here. I think I need to clear a little bit of room. I actually wrote down a bit of an agenda today to keep me a little bit organized. So we have concluded the non-laser stuff. So now we're gonna move to the laser, finally. After 2 streams, we are back to the laser. So I will just toss this box to the side. I think we'll leave the lights on. They're kind of nice. We will kind of be back and forth between these, but we are coming back over to the computer. We do have the camera at a slightly different angle now. It's lower down because I have it on a little tripod. And I have it on the tripod because the monitor mount has been a little bit frustrating. That charged, good. So we'll get the laser booted up in a little bit. Let me get our light brought over, which that actually works out really well. Let me turn that a little bit brighter. I'll swap cameras for you guys. All right, let there be light. So I think we'll start this with basically the simple concept of how do you focus a laser? What are your telltale signs? And I know of 2 methods that I have used that are fairly effective. So we'll do both. And we will see about background noise here, but we're basically going to use paper as a easy to mark material. And we can either look at the fineness of the lines, or we can look at basically get like auditory cues that tell us the laser is being effective. So why don't maybe I'm gonna check in on the audio. We'll start the laser and all of its fans that always kick on. And let me see what this sounds like. We'll just do an audio check just for sanity. It's not unreasonable. Let me try the sound suppression. So this is my voice over the laser with sound suppression. Okay, not a big fan. Let me try the mic arm, which I'll enable here. There we go. And now I can also hear, and you guys can hear double. So I'll turn that off. And we'll throw this in the charger. Why not? I guess I don't have to. Indecisive, as goes the late evening. Okay. So I can hear the background noise. It's I think it's reasonably manageable though. So let me get this camera pointed over. Did I already preset maybe? I did. Look at that. So let me also mute my own stream. We have a sheet of paper, and there is a red laser dot from the laser. This is used for focusing, but it may not be calibrated when you first get your laser. So we're trying to establish a very basic initial thing here, which is laser focus. This particular laser, I need to have some method of viewing the UV light. So I think you can see that green light now as it hits the self-illuminating acrylic. And that just tells me that the beam is on. My basic rule of thumb is if the laser is on, if I can hear the laser, my goggles already need to be on. So we have a ruler and we are given a reference line on the laser itself. And when I got this laser, they gave me like a sticker or something that gave a millimeter distance. And you're meant to write down the focal length for a given lens. So you'd measure from your object that you're engraving to the line, and that would be your reference point. There's also a line where the two shells of plastic meet on this laser head. So what can be is that your laser is not in focus, or the measurement they give you is not accurate. And that was my case. Mine was not accurate. I think we may adjust focus here. That's exposure. Let's go for global. Let's see. I think that might be okay once we tilt back down. That seems reasonable. Okay, so I have calibrated this before, but I seem to have misplaced the distance. So we're going to recalibrate this so that moving forward on these other projects, I know what the heck I'm doing. I just have a piece of black cardstock here, which is quite markable, and the grain of the paper is fairly fine. which gives me a good degree of control. So I might actually plug in my alternate webcam here. Guess I'd unplug that to make it happen. One thing about these cameras that I have is I can't input twice. I have to run it a certain way. So hopefully this does recognize. We'll replug it. And I think our laser is actually writing the threshold, basically the noise gate on my audio channel strip, my processing. So let me see if I can't turn it up and test that. It's almost a little bit more distracting. So let's try a more normal setting and we'll just rock with that there. Okay, so I should be able to bring you guys a view of little old me. Just have to bring this all the way up. There we go. Looking super cool. We have an ad coming up in about 2 minutes, friends. Apologies for said ad. All right, now at least I'm kind of looking towards the right thing now. I do have the dilemma of it being extremely cold outside, and you can see my vent in the background, that large ducted fan. That's what extracts the smoke. I'm going to avoid using it as long as possible, as long as I can tolerate, because I don't want to open a window to vent outside and bring in super, super cold air. So I think we've got a little bit of a setup here. I can also bring the application up and we can get a peek at that. So I use Lightburn. It is laser control software so that you can operate your laser, but it also has some design and layout functions which are incredibly helpful. I will try to bring my YouTube up just on a separate screen. Those ads are about to start in about 10 seconds. And if you are still here, I'm just quickly looking through my tabs, which I think I just discovered something that is annoying, but really good to know. I had grouped the tabs where I had loaded up friends on that are streaming, and I grouped them into a tab and called it Lurks, so I could open and close it and clean up my Chrome browser so I could navigate and do whatever. What I just noticed when I went to check on them is that they were all reloading. So I think when you group tabs like that, they go into a sleep state, which is no bueno. You don't count as a lurk there. So we're gonna fix that shit and just have that up now. So I'll wait just a minute. I'll take a quick break, get some water. But we will carry on all the same. What I'll do is design something very simple that gives us an idea of the thinness of the beam. this will be our first test. This is where we're going to visually look at and compare the beam width. I don't have a microscope, but if you did, you could maybe actually physically measure it. So let me get a little capture here for you guys of the display. There we go. So this is Lightburn. This is the design side. And if I disappear myself, the laser control side is being covered up by me, but that's quite simple. Well, relatively, I guess. Not what we're looking at least. So this is the design side. All I really have to do is make some kind of repeating pattern that is easy to distinguish. So there's kind of a default grid system that you can snap to initially, but to get this to go in a straight line, I had to hold shift, and I'm still new to this software, so I will figure out how to release this. There we go. Just don't move. Right click and you will erase the second line after your second node. And now I have a line. If I go back to my selector and select this, I can now click the array function. And this is just a way of iterating something or repeating it. What I'll do here is dial up the Y coordinate rows, and that's just adding a variety of lines. I'll go ahead and fill this. These should be centimeters squared, so it should be 20 millimeters by 20 millimeters, which is a decent size. And this is essentially all I need to do. This will tell the laser that I want lines all the way across, as long as, and let me toggle myself, on this right side, I set the mode to line. There's different modes here. Line and fill are your primary modes. Fill would look at a box and fill the box. Line would draw the line of the box. As for settings, you just want settings that won't completely go through the material, and that will give you a easy to see line. On this laser, it doesn't really burn, so I'm looking to mark things. On a diode, you would want to leave a burn mark, essentially, so you'd just be dialing certain settings to achieve that. Obviously, you could also cut a hole and compare, dial your settings until the point that you can tell when it's most effective, because a cut is actually getting all the way through. And I completely forgot to turn a light off. Which may also be kind of ironic, because it might have been helping. Let me just look at a view of the room real quick. If my camera will do things. Interesting. I'll just I am. Oh, that would be because I'm on Logic. Silly me. So if I drop these two, I can see the room. That looks a little bit better. Okay. So not as good lighting here. I'm definitely backlit. Perhaps, pardon me for my lighting obsession. I can plug in this little lamp that's off to my side. Let's see here. How have I done? There's a little bit of side light now, so that's somewhat reasonable. Okay, I will attempt now to get the laser set up here. So I have kind of a general setting that I know will work for this, and I have that written down, though that is from a different project. So I'll guess a little bit, and I will run a pass. Okay, that was quite quick, as it should be. Let me give you guys a view of that. And actually swap to the appropriate camera. Thank you. And we just did that. I'll move the laser over a touch. I'll actually center, that I think was the main thing we just did, is this was not centered. So let me see. There's no right click align, so I'll select this and look at my alignment tools. Appears I don't have an option, so I'll just visually align it. Should be roughly here. Now that should land under my actual dot that's over there. So we'll run this again, and it's very quick. And at this point, I would take this off and look at it closer. I do actually have eye loops, these little magnifiers, and I can get a closer inspection of those lines. And this is what I have to do with this laser. I cannot tell with my naked eye anymore because the details are so fine, which is a wonderful problem to have. This laser has two lenses. The 150 millimeter field lens will basically work within a box of 150 millimeters. I have a 70 or a 75 millimeter one. That will actually resolve more detail, though it won't cover as much space. And I haven't even tried that lens yet because I'm really impressed already with the 150 millimeter lens. So we've just been working with that. Eventually I would have to do these same things on the 70 millimeter lens to learn its specific functions. So I got a result, which this laser should be in focus at the moment, but I'll just measure this. And we are basically dead on 32 centimeters. What I can do as well is back in the software, I can make a text layer, and we'll do this as 300 millimeters. I will make this smaller, so the height of the text up here is just in millimeters, so I feel like something around actually 5 millimeters high looks good. I'll grab my select tool and drag this back closer, and then with it selected, I'm going to grab a different layer. We have a new website to ban, everybody. Fantastic. I love when they do this because I happen to mod on a few of my friends' servers, and I can go add this to all their Autobots. So I will just do my routine, which would be reporting the bot. Takes a touch longer Well, it does take actually, it takes time. But banning, I don't know necessarily reports them. It just removes their message, and then it's the easiest way, obviously. But I like to report since typically chat isn't too crazy, and I can try to do my part here to keep Twitch a little bit cleaner from these crazy peeps. The other thing I can do would be in my settings. So I think it's creator dashboard, settings, stream. I may be wrong. Just going off the vibes at the moment. Okay, so there would be... There's an auto mod page somewhere. I guess I'll just go to moderation, settings. I think this is it. Scrolling way down. And there should be... I only do this every couple weeks, it seems like. I'm in the right place. Just the layout of this is incredibly annoying. So I don't think it's under advanced. There we go. Blocked terms and phrases. And then I just add the website before the .com to my list, and now that will auto moderate for me in the future, which has worked when they don't change it. Obviously, they love to change it up, but what can you do? Okay, so we got that little thing dealt with. Back in the laser software, what I'll do is I've moved our text to a new layer. I will copy my settings from the first layer now to the second layer because the result looked good. And I'm going to set my second layer to fill because I want the lines to fill between. I don't want to draw the lines. So I can also now toggle the output of our first layer. And if I get rid of my screen here, when I run this, there is now text that is misplaced. Let me guess that approximately and run that again. Okay, now we're close. So all I have to do is, when I run a new test, add a new distance, is update the distance. And then I will get my test grid and the specific distance that it was at. And all I have to do is run this until I find the sharpest result. You could maybe go up maybe even 2 millimeters at a time, maybe even 5, quickly find a range and then go much, much less than that and dial in your focus that way. And then when you're done, you could cut out the good result and keep that one piece. And now you have a copy that tells you. What I could actually do is even just tape it to the laser head. I could even add text that says 150 millimeter field lens is 320 millimeters. So to give an example of out of focus, let's adjust this up. So I'll pan this up for you. This has a motorized gantry. So I'll just press the button a couple times. 3-ish times, and we'll get a measurement now. So from that reference line down to the top of the paper, we're now at 326 millimeters. So I will update our text layer to 326, and I will line up my paper. I can also see that my red dots have now diverged. There's actually 2 lasers up at the top here. You can see one of these here. Two visible lasers. They're just loosened. They're kind of like in a ball and socket joint. You just loosen the screw and you can point it and then tighten it back up. So I have already set those up. So my laser dots here, the visible ones, have diverged. Let's run this. And now a couple interesting things have happened. For one, this is much dimmer. You almost can't see it. It's between my fingers. So it's much fainter. We're not affecting the paper as much because our laser beam is being spread across a larger area. Let me find my loop. And I can look at this. And potentially see a thinner line. So what I would do is, I know I've gotten worse, I would go the other way. So we'll move this down. I will measure. We're a touch high. I want to go a touch low. So we're going to go 319 millimeters, 1 millimeter less than my best focus. And I'll line this up and run this, which you saw, good. And now I can compare that result, which seems very much identical. I'd like to show you guys the actual thing here. So I'm going to try to set this up for you. I set this up before stream, but hopefully I can get this to work. So behind me is my camera. Right there. That is my mirrorless camera. And let's swap back to the wireless mic, which I still have on because I never did the thing. And now I can walk around untethered, and good grief, that laser is noisy. So I'll leave the glasses on, that's my rule. I'll bring the paper with me, and I'm going to turn this camera on, get it connected back to the computer. What I'm hoping to do here is run an app called Lumix Tether, which I think I'll need to close and then reopen. It was a little bit finicky, and I considered keeping it running earlier, but YOLO. So that's restarted. I'll restart the camera. It's giving me trouble once again, which is appreciated. Don't know why. We'll just try things like I did earlier and hope it works. Flip the USB around. It's a Type C. which should not be a problem, but you'd be surprised how that fixed it. God dang it. I hate that. Type-C is supposed to always work. Do not open that now. Okay, so now I can start the software. I'll try to give you guys a view. We'll just do Acer Screen and Logitech. So this is the software. It is camera control over USB with this little remote setting. This just, you can even dive into the menus basically. But what I'm after is live view, and then having the pictures get saved to the computer. So I've just set it up as a dump folder basically of my pictures, which I'll leave there. But this will kind of give you guys a little bit of a view of what's going on back there. So I'll go set this up. Which is a little bit annoying to do with dark goggles on. That's how we're rolling. I've got a couple options. I could hold this, which I think we may just do. I've got a little helper arm here. And doesn't seem to damage the paper. And then you see how that looks for you guys. You can kind of see what I'm doing. So with the live view, you'll see me start getting this kind of lined up. I'll just bring the camera up. Oop, not quite there. There we go. This would be nice to set up one day to have like a little macro booth where I just bring something in, hold it for a split second, and then the photo gets taken. So I've got a spotlight here that will just give us a ton of light as needed. And I'll focus this lens for you so you can see what's happening. So we're gonna look at the 319 millimeter spot. But this lens, the way it works, it's a macro lens. It needs to be in the proper range. And for this, it means it needs focused all the way as close as it will go. And then I have to fine tune the distance here and get everything reasonably parallel. I think I'm probably okay to adjust the focus just a tiny bit to really fine tune it, which with mirrorless cameras, you do have focus assist settings, so you can punch in and look a little bit closer. And I'm gonna just square this off visually. Zoom in again and focus. I'll turn the aperture up so we have a bigger depth of field. I'll go to f8 and turn up the brightness of this light considerably, and that has helped to bring our aperture down, or our ISO, adjust to a fairly fast shutter speed, and turn my light up again, just balancing everything. And I think if I were to actually drop the camera slightly, I would get a better view of this. Get the 319 millimeter in. All of this just to get one shot. Hey, okie dokie, welcome in. One shot for you guys. But obviously, when I go to edit this stream, like I plan to do with all of these, this will take literally a split second for those lucky people. So I'm just adjusting the focus again. I'm pretty happy with that. And I have two options here. I'll do the first one. And then I'm going to do the second one and come back over. And we'll compare these, because I am very curious. I'm also curious to know if my freaking phone is as good or better. How you doing, okie dokie? Good to see you. Thanks for coming by. So let's swap microphones. Hopefully get a little more noise isolation here. And put my headphones on so I know what the heck's going on. So we've taken some photos in the background here, but now this is still a live view. What we need to do is go into our pictures and bring these up. Now this first one, when I open it, will be viewable for a split second. And then it'll probably turn a weird color, though it seems to have stayed. This is not a raw viewer as far as I'm aware, that the default setting's raw, but if it'll let us, it doesn't really let us zoom in. So that's not the important one, but the default resolution of this camera is 24 megapixels, and not my computer freezing. Just trying to look at a photo size. So 6,000 by 4,000 pixels. This picture is 12,000 by 8,000. So it is double the resolution in each direction. And the way that's been done is there is a high resolution mode on this camera because it has a stabilized sensor. That's not at all what I wanted to do. Thank you, Windows. There we go. It has a stabilized sensor, so it can actually shift the sensor in place very slightly. So it can move it like a half pixel increment each time. And it can move it in a square and take multiple pictures of a static subject, and you get more resolution. Now, actually looking at this, of course, the results may vary. And I'm not getting the crispy, super crispy result I was hoping for. But we have gotten a result. And this is kind of the important thing that I wanted to show you guys. The fill on a laser is just lines. And you have to tune the interval to bring those lines together. Basically to have them nearly touch or to actually touch, but not overlap too much. If you overlap the beam, the power will double up in a spot and you will get more damage in that area. That may not be what you want. So it's a fine balance of seeing these lines between the fill versus not. The real trick would be to have a perfect setup, ideally like a microscope with a very predefined distance, and I would just move this paper and slide it along a plane. I don't have that set up. I could maybe rig something with the camera, but I don't think this is going to be our winner for this test. If we were to compare the widths of these lines side by side, we'd need a perfectly consistent result. But a different way of testing focus is to look at these fill lines and see how those go. I want to say but again. That's been my word this evening. What I think I want to do though is change lenses. So we're on a 50mm macro lens, which means we can only get, at least on this lens with how close it focuses, our 1:1 representation is probably 70mm from the end of the lens or so. I have another lens, and before I put it on, I may actually Google if it doesn't show me. Yes, I will Google on camera briefly. So it's a Sigma 105 macro lens. And if I can find a website that I enjoy using, macro, and then I'll search a website that I like to use. I believe that is the correct lens. I'll go to specs. So the macro reproduction ratio is also 1:1 on this lens, which is all I need to know. I will get a likely tighter crop that is identical, and that is not what I need. You can extend a lens. You get, looking at you guys through a screen, you can get macro extension tubes, and they move your lens physically further from the sensor, so it effectively enlarges the image and you crop in closer. You will lose sharpness, you will lose depth of field, the depth of field will get much shallower, and you will lose light. But if your resolving power on the lens is already exceptional, you can afford to do that, and you can go past your reproduction limit on the lens, the scale. Here, I'm not thinking it makes sense to do, but I do want to test my phone and compare it. I am a little bit wary that at the end of this, I'll look back and one result was completely fine, and I just had dark goggles on, preventing me from seeing what I need to see. But let me give this a try, because I also want to compare this phone. So this is a Motorola Edge 50 Ultra, which I got as an upgrade from my last phone. I primarily got it for the camera system on it, but that comes with a macro mode, which obviously any phone's probably gonna have, but I've been really, really impressed with it. So I will go to my macro mode, adjust my exposure. I think I'll have to line this up a little bit better. And it's letting me get quite close, but I do need to find the proper focal distance, which will be somewhere probably in there. Take my photo. And zooming in, it looks a bit blurry. That could just be moving it, so I'll try again. This again might be something to have a proper setup for. So it looks like the macro mode is done from the wide angle lens, and it seems like it crops into the wide angle lens, which is maybe not ideal considering you're already losing resolution. So let me try with the normal lens. And then the telephoto. And I'll compare those. So the normal lens may actually have more resolving power, focused at its minimum. And the telephoto either has ghosting, zoom, focused all the way this close, or it was a tiny bit of motion blur. But I can also still see quite a bit. So let me test the wide angle one more time for science. I have to say, I think the 1X and the telephoto are better. The 1X has a little bit more resolving power. Obviously, the easiest thing to do here is grab one of these eye loops and focus through it. So I will do that with my 1X in the high resolution mode. And we'll lose some optical quality, but we'll gain a lot of magnification by doing this. So let's take a look at that. And that might be our sharpest result yet. I'd like to retry it with the big camera as well. The result was not as expected, so I may have been out of focus. So let me try that again. Lots of back and forth. So I'll get close, move back a touch, square off, we'll punch in, and I will rack focus until it's sharp, sharp, sharp. In the high resolution mode for JPEGs, with a pretty fast shutter speed. Dial up my light some more, and we'll shoot. We should now have that photo, which we can load over here. And let's look at this one. That's a much, much better result. Definitely workable here. So, good deal. So what we've achieved is now we can properly see the laser width at 319 millimeters. And I think while this test might be quick and dirty with the lines up top, I think just doing text filled in could give us a better idea. And there's a couple thresholds I'm thinking we could play with. One would be the line interval, which at this distance, I could adjust our interval until it disappears. And I think I'll do that, but I'm gonna lower this even more. I'll just grab back my paper. And I may even cut a square to work with. That way we can... That way we'll be able to work this a little bit easier. It is so incredibly dry, like low humidity, because of how cold it is right now, that I keep getting static shocked through my ears because the headphones are grounded and I keep picking up static. It's not bleeding off into the air. So there's absolutely zero moisture in it. So that's nice. I hear a big old pop and then I feel a sharp pain in my ears. A mild pain, it's not too bad. Okay, so let me drop this to more worst case. So if we're thinking 320 is our spot, we're at 319. That would be 318. So I'll just update our software. Text to 318. I'm going to double check, just a sanity check. I don't want to be wrong. All right, 318. I'm going to toggle off this first layer and grab this, and I'm going to just center it so we can predict where it's going to end up on our paper. So one challenge of this is you want your paper to lay incredibly flat, because if you don't, you could be skewing your test results. So you want to have a flat reference. Honestly, even the sheet that I have this on, I have like an aluminum backing sheet. I'll show you. Maybe. Oh. This is what we have to do. There we go. So this sheet I'm going to get rid of. It's just to protect the black anodizing on the base here, in case I were to punch through the paper. But it is not totally necessary for what I have here. Kind of want to steal this back. I'm trying to locate something that has a hollow center, but also has some weight to it, like a large washer, or a couple fairly flat things. And I'm kind of drawing a blank. So I may just grab some magnets. The base is not magnetized, but they're flat, and I keep shocking myself. This is miserable. Okay, so I'll set this off to the side here. And now I can tell that the paper is relatively flat. I may even move this one to that edge, and we'll slide that just a little bit, and that should work. So now we're perfectly flat. We're on the base of the laser, which should have a really good reference to the laser head. Should be very much parallel. And now we can run our tests. So we have 318 written out, which is actually going to be incorrect now. So I'll bring in a piece of paper as a reference. Thickness, just so my ruler has paper to rest on. And measure this to the side. Is off. So let me adjust this manually. Okay, that is 318. And we'll run this. And I'll take a look at it. This might already be a pretty darn good example. Okay. That's 318. We're going to move to 319. If I get the ruler the right way around. So all we've done is move 1 millimeter. I'll update my text layer. To reflect. And we'll run it. We have a result. Slide that down. I'm going to adjust to 320. There we are. Update my text. Run it. Shift my paper. We'll go another millimeter. Let me look at the gantry manual adjustments. Hard to nail. But it moves a lot quicker. So this is 321. Run this. Shift my paper. And now we'll go to 322. Update my text. We'll run this. This is at a 0.1 millimeter interval, which is fairly coarse for this laser. But now we have a sheet with backwards numbers. With our numbers on it. I'm going to take this over and we'll take a series of images. One of each text. And you'll see me in the background here. I might as well swap. You'll see me in the other camera. So we'll switch to the screen. Go to our preview. Bring the preview over for you. Let me see if I can get live view actually. There's our live view. I think live view might be more fun. So we have live view. Swap mics. So now back over here at the camera. I'll place my paper on our arm. Move minimum focus. Find that. Move a touch out of focus. Okay, now line these up. So we have 318. Just crop in to see how we're looking. I think I may just slide this back and forth to find our focus. I could even make my depth of field shallower, going all the way to f2.8. And that will tell me a lot closer to what's perfect. And then I just move it back to the f8 that I had. And I will let this run. So it's taking its image now, processing. And we should have a result. I think I will just double check it. I don't have a pre-shutter delay set that's very long, so I might actually be introducing some vibration into this. So let's look back here. And zoom in. That seems reasonable. I somehow feel like it could be sharper. Obviously, that's plenty of resolution to see what's going on, but let me just adjust the delay. We'll set it to 1 second. Actually, let's do 2 seconds. And we'll tell it to try this time to remove motion blur. I don't know that that's the right decision. We'll also manually focus. Bring our aperture back. And we'll take a look at this once it transfers to the computer. That is extremely sharp by comparison. So mode 2 tries to remove motion blur and mode 1 does not. So I'm gonna go with this. this is kind of the result I was expecting. So now you guys can really see what's going on here. This is the quality content that I wanted to provide. So we can see our line interval of 0.1 millimeters does have gaps at 318. So, and we actually have 390. Why wouldn't I do this? Get multiple in frame. It seems like it's sharp edge to edge. So let's redo this, get everything in frame. This is where a microscope would be incredibly handy, because you could just slide this and be done with it. But alas, I don't need another hobby like that. Although I will have a something similar one day. Once we get into the electronic side of what I want to do. Okay, so we've got that photo saving. We had our 20 in frame. I'll just arrange this now to center on our 21 and 22. Try to get it square and parallel within reason. Open up my aperture again. Get it very close. You can actually see how the 321, I don't know that you can see that. We're looking at the back of a can. It's riveting content for you guys. There we go, there's a live view. So you can see how the 21's not in focus, but the 22 is. I think that's because our paper is laid back slightly. So I'll try to adjust to get those both in focus. That seems better. And I'll slide this past focus ever so slightly. Really need some precise tools at this scale. And then I will punch in zoom. Which I think we're actually in focus. Just the depth of field is limiting, so we'll run this. That will be over here to save. Okay, we have that result. Let's go into our pictures and bring up our photo. So this is our 18, 19, and 20. And then we also have, we should have our 21 and 22 next to it. Silly windows. Let's see if I can open just 2 photos. No. No, I can't. There, it does work on here. Okay. So I'll just drag this over. Make it a bit bigger. Okay, now we can look between these two. And let's look at our 18. We have lines that are defined between our fill. Our 19 is the same. I feel as though the lines might be a touch closer. Back on the PC mic now. Let me throw on these shocking headphones. And let's look down here at 20. 20 seems to be about the same, honestly. A little bit surprising considering the difference in distance that we had. 21 seems about the same. 22 for some reason looks much more spaced out to my eye. So perhaps this was not the result that I expected. I was expecting it, if it was very much out of focus, to fill in the gaps between, because the dot size would get larger. But I'm thinking that maybe this paper is just a bad idea in terms of laser accuracy. I do have some metal sheets I could use. Somewhere. I have some sheets, I think just outside the room. So I think I'll grab those and take a quick break. We'll be right back. We're back. It is so incredibly cold. But we've turned the thermostat down a little bit extra this evening. Hopefully that's a good thing for the pipes, for the faucets that we have dripping. I think we'll be okay. I hope we're okay. Okay, so I have a sheet of aluminum flashing. I don't think the thickness is particularly relevant, but you know me, I'm gonna measure it. So I've got it right here. We're looking at about a 1/4 millimeter. Yeah, 0.25, 0.24 millimeters. This is probably meant to be, is that 95 thousandths or 100 thousandths? It's probably trying to be 0.1 inches. And we're just catching one side of it. 1/64 of an inch. But I like the metric system for my brain. It helps. Thickness, though, not relevant. So this is a sheet of aluminum flashing. This is used in the roofing industry to provide a barrier to water. They tuck it under shingles and fold it and do all sorts of stuff. I happened to get a roll of it. I don't know if it was on sale, but I recall it being about $64 for a roll of this stuff. And the roll must have been 7 to 10 pounds. It's maybe 2 feet wide and, I don't know, 60 feet long, let's say. Really good deal. Now I think it's at least double. I wish I had bought all that was available at the time. But anyway, the sheets come out fairly flat, but it's just thick enough that you could maybe work with it to make a small box or different things. You can use the properties of it being aluminum, where it's going to pull heat away decently. And that's kind of what I've imagined it for, some different projects. But what we're going to do here is use it because the grain structure of metal is going to be so much finer than paper. So I have a marker, and I will just scribble across and create even lines. I forget what this process is actually called, because it's used in machining a lot. Where machinists would use an ink or a dye, and then they would scribe their lines, their reference lines, onto this. But what we can do here is use a very low power on this laser to remove the blue from this sheet. It is an alternative to removing anodizing from aluminum. This is not anodizing, this is just ink, but you can do this with very low power. So I think we're going to repeat our tests here and see if we can get higher resolution, because I think our grain of the paper is simply too thick. So coming back into our software, we'll still be at 322. So I may even bring this down a ways. I guess I could give myself a line to reference very quickly. So I'll just draw a line top to bottom. And I will put this on a third layer so we can toggle it separately. I'll paste my settings, turn off our text layer. I will run this. So now I have a center line that I can reference off with my focusing dots, which those are slightly offset. So kind of just mentally memorize that. And now I can move this down along the line. Near the bottom, I'll offset it slightly. I'll run the 322. Ooh, that looked very nice. The way it interacted with the metal. Fucking gorgeous. I'm really excited for this. Okay, we'll scale this back as we have been. And we'll go 321. Not actually 321. I just realized, because our material thickness is 2.5 times thicker than the paper. So we're not being terribly precise here. Okay, this will be 322. We'll drop this down to 321 now. Close enough. Change your text. Run this. Let me give you guys a view of the laser as well. Just position it. I have my reference line now, so I can kind of align it a little bit better. Hold up my ruler, referencing off the material. Bring this down to 320. Which I've been lucky. Between up and down, I can get it pretty close. So there's 320. We'll run this. Very lovely. Slide along. We'll go for 319. Seems to be working using the buttons, just momentary presses. There is position for 318. Let's drop this. The last one was more like 318.5. So maybe we'll go down a little bit further. We'll do 317. Okay, another interesting result from this. This is probably the way to do it. It is, well, at that angle over there, if I can maybe give you a reference, some way the light was setting. Yeah, somewhat like that. The lower the number, it seems like the fainter it is. So you can see the intensity when the beam is closer, or sharper, I should say, is higher. Though, we did have more... The ink is not consistent. So there's a chance that that is actually impacting what we're doing here. Let me take a closer look. Unlike anodized aluminum, I don't know that we're leaving ink necessarily between lines. It may just be ablating it all. But the real test is with not dropping it and bending it. The real test will be with the macro shots. So let me scrub out our one that we're not counting because it does not represent its distance. And we will head back over to the camera. Yep, that should be the live view. And now back on the wireless mic. Coming over here. We'll swap this out. Swap in. This, it seems like it's fighting a little bit more. It's much heavier. But I will try to position it parallel to... Of course, you can't see that. There we are. Trying to get this parallel there on the live view. It would be nice to have it full screen over there. I could really focus well. But we got a lot going on over there. So that's roughly centered. I kicked the camera. Good job, me. So we can fit 22. Maybe we can slide this then. Can't quite fit at everything, so let's give ourselves a little bit of margin. Capture that one. Adjust this back and forth. I'll punch in again. Get my depth of field just a bit better here. Let me move past slightly. Focus back into it so I know I'm getting focus. Even just letting go of this has caused a surprising shift in focus. But it looks like we're fairly in plane with it. So I will increase our depth of field, take our photos. That is sending over. So we got about 319. So let's swap to really just about there. Zoom in again. And focus again. I like that. I think that top is slightly out of focus. I'm going to scoot this just the tiniest bit back until it's just ever so slightly out of focus. Bring that back. Find a balance between the two. Maybe focus in the middle instead. Slightly out of plane, about there. Bring our aperture up. Hold still and take our photo. Okay, photo's done. We'll let those send over. While that does send over, let me swap here and check on my tabs. Which we had one to reset. We have one to close. Two to close. One new one to open. Very good. Okay, we'll bring up our pictures. Man, I don't know why it does that. Guess I'll open from this one and maybe it'll let me scroll to the side. There's an old photo. No. Windows, you are garbage sometimes. I would think I could just open two photos if I selected them. I guess I could open them in a program. That might actually be the way to do it. But it was nice having the photo view. Let's see if that will load too. Not at all. Oh man. I guess I can open GIMP. Silly limitations. All the time. Every day. There's always something silly going on. Getting in the way. So this should just let me load in a JPEG image. I'll basically just drag and drop both of those. Take a second to load. These are actually somewhat large files. Keep the original color profile. Now it's loading in both. And we can look at each photo here. So that should work for us. All right, let's look at 17. And taking a peek here, we can see the edges. Do I have a better pointer-ish? Very, very nice resolution here. And I love the, almost the star streak effect of the, it looks like it's a brushed metal effect, but I think it might be from the rollers that press this material flat. But looking here, I don't see very much of a gap between our lines, like especially the top of the 7 looks very filled out. It also looks fairly thick. Maybe it just hit the threshold of adding another line, or that's just how 7s look. Looking here at 18, I can see the faintest line now. This resolution's working out a lot better. We're really starting to get this system dialed in. See how our 18 does actually show a line. We compare the M over here. I really don't see one. Now I can. On the 19, it's even sharper now. So we're really able to define lines between our laser lines. Okay, 20, even a better result. Still, my goodness, this is This is absolutely gorgeous. Holy fuck. I might need just a macro shot of the blue ink over this with the side lighting, the slight shadows that are cast in the grooves of this, but with the highlights, it looks like almost an aurora borealis in a way. But God, it's beautiful. Okay, distracted again. So we've seen 20 on our last, correct? Yes. And it was looking mighty fine. It was an improvement from the almost blurriness here. This is looking much sharper. Now over here, it doesn't look as sharp, but I think that's exposure related or even just the focus related. But we do know it was a better result. It's the same 20 as before. Now looking at 21, have we improved even further? I think yes. And down here, wow, always at the bottom is the prettiest. 22 seems immaculate. Just the fine detail of the beam itself. I would imagine as we would go out of focus again the other way, it would just regress as it has been, where the lines seem to get less defined. If we look at the bottom of this too, that is incredible definition. And a lot can be told from this because we're dealing with different frequencies. So if I look at the laser again, and I'll hide my view so you can see. If I open up my laser settings, which I can bring myself back now, you can see we ran, pardon me, at a frequency of 33 kilohertz and a Q pulse width of 500 nanoseconds. So there's some interesting things we could do here where, depending on the pulse width, the frequency, and even the speed, we can definitely affect what is happening in this line. But I think 322 millimeters in this test, at least the way that we performed it, seemed to have the best effect. I would absolutely say this looks to be sharper than any of these other results. How the line itself seems to be almost out of focus, but here seems to be in focus. I will do a sanity check with a 10x eye loop. See if I can't tell by eye. Definitely not. So I was questioning the necessity of a setup like that. Macro lens, high resolution camera, simulated high resolution camera. Just getting as much resolving power as you can get. Oh God. Yeah, with the 10x eye loop, I cannot see any improvement. I cannot tell you the difference in the sharpness between 322 and 319. We could be splitting hairs, but to establish for this laser its absolute best focus, it's worth doing once to me. And this is just the one field lens too. I have another field lens, which isn't calibrated yet, but theoretically the line would be even thinner. The yawns are attacking me at the moment. Good grief. So this laser, if I look up its specs, see if the Google can pull it. Ah, yeah, it did. So they claim for this laser that the small beam dot size is approximately 0.0019 millimeters. So 19 thousandths, 19 ten thousandths of a millimeter, I think that is. Basically 2 thousandths of a millimeter, which is incredibly, incredibly small. My last laser was, I think, 0.0. Let's look it up. It's a Sculpt Fun S9 dot size. Oh, 0.06 by 0.06. I thought it was 0.08, so it is a little bit smaller. Get out of here, yawns. And not a symmetrical shape. Slightly larger in one direction, slight oval. It is two diodes combined, I believe, so you can have some dissimilarities there. So I can't math the difference there. I guess I could ask the Google. .06 and 0.0019. Let's see if it gives me almost the same dot size again in difference. So nearly 100% smaller. I'll ask for a percentage. Well, I didn't do what I wanted, and I'm not, there we go. So it's almost 32 times smaller, according to Google AI, which I don't trust as far as I can throw my CRT monitor. Ooh. Don't trust as far as I could throw the dumbbell that we unboxed a couple hours ago. So yeah, a 31.5 times smaller beam size. So yeah, I'm definitely in a different world of these eye loops. These used to be absolutely adequate. I could do paper tests. Now we're well past that. We need a finer grain. We need a finer grain or just a finer surface finish to work from. I would be curious to go further. So I had run the laser at 320, I believe. It's looking like 322 is even better. So why don't we push this? It seems to be improving continually here. I think we need to go to 323, even through 325. So I'll just set this up. Get my weights on it. I'll dial this in. which I would love to do. However, this is slightly out of alignment. Just place that there, I guess. Okay, that's 323. We're going to hop back to the laser software. And let me get you guys a view now back over of the laser. I'll just approximate this. So that was there. I need to be about there. Square that off. Be nice to set up a jig one day. 323. Okay. Move this up. That'll be 324. Hopefully I'm consistent with how this lines up. Let's see. It's reasonable. Okay. 24. We'll go to 325. Maybe even 326. Awfully close, within 1/4 millimeter. Okay, this is 325. Let's write this down. There we go, 325. Let's do 326 just to the extra thrill. Okay, line this up, update our text, run it. Okay, now we have 4 more results. The colors are more consistent. Sort of how I had viewed this before, where it seemed like the lower numbers were less faint. It seems as though we've continued to improve to the point I can actually tell with my naked eye almost that 326 is looking pretty good. To the point that, one, I'm surprised that we do have this focal range. And 2, I think we need to keep going. Just looking at this. So, we shall. Need to get my focus. So we're going to 327 now. Yep, within 1/4 millimeter. Update the text. Let's go for 28 and 29. There's 28. $29. And it's about all I have room for, unless we add more ink. Let's see what I can see. Not a huge difference, but I think we need to take some proper photos of this now. So swapped mics over. We'll head back to the macro rig, which I just now realized we could hold with 2 hooks if I set this up right. And maybe I even try to go super extra mode and get my macro focusing rail, which I think we will. I wonder if the humidity is going to go down as I open this dry cabinet door. Yep, it was at 36 when I opened it. It's now at 35. Where is the rail, honestly? If it's in here, it doesn't need to be. There are some macro lenses that are like a 2x representation. Laowa has them. Oh, our humidity's gone up. I am talking into this, though. That could be why. Which is a possibility. I mean, 2x zoom is very significant, but the real way to do it, it seems, is to buy or build bellows, have a rail to focus the camera, and then get a microscope objective, which is just a very, very, very extremely sharp lens that projects an image that would be typically recorded by or viewed by an operator of a microscope. Let me get this situated as well. And it would be really cool to build something like that. There's some really neat features and things you can do with that kind of optical resolution, if you can get the control that you need to make it all work. Let me swap to live view for you guys. So we'll go and bring up the screen, go to Linux tether, and then we'll also, that's all we can do there. So I'm a little bit off frame here, but currently swapping out the base plate to put onto a macro rail. It's a linear guide. And I think I kind of want this to one side, I would think. That would give us the most range. I'll just kind of do the middle. We don't need all that much range for what we're doing here. So with the microscope objective, you don't get to adjust aperture. It's a fixed aperture. So your depth of field is going to be minute, like absolutely insane. The way around that is to use some software that will let you stack images, and it will process out the out of focus areas with areas that are in focus. And I think my photo software can do it, which is now free, apparently. Affinity Photo. So if you can get access to that and it has macro stacking abilities, absolutely use that. Otherwise, there's another app called Helicon Focus, and it would be the old school way of doing it, I guess, nowadays, but certainly still an option. But with a microscope objective, the software to process out the out of focus areas, and then an absolute shit ton of photos, you can get some incredibly like depth of focus and macro shots. You can do absolutely insane things. And for something like this, I'm actually thinking I would see the benefit. I maybe would not have been convinced of that 2 hours ago, but now I think I am. Now I definitely think I am. I will try to just level off my camera a little bit better. And of course this is very shiny. So I'm trying to figure out how we really want to light this. We're using a spot source because it is very concentrated, very bright. But now we have you guys on this camera on a rail, a geared rail, and you can see all the absolute shit for mechanical precision it has. But we can move back and forth fairly precisely. So we can stay at our maximum magnification and now just move the camera back and forth. Obviously, again, we have so much play in this setup. But if we work with that, I think we can do some decent things. So I don't think we're quite parallel. Just guess, I think. It probably wouldn't be that hard to make some type of mount that would push off the lens and keep things at an exact distance. Then you just slide it along the plane. But looking at this, our 29 has gotten quite into focus. And that's near the bottom. And the top isn't looking too bad. It would be nice to have this squared off. So just adjust a few things. Pivot all this. Lots and lots of setup here, isn't there? I'll widen my aperture quite a lot. And let me get rid of that zoomed in view, and we'll head back to the top here. I've never thought it would be nice to have an like a cranked center column. Sounds sus. To adjust on a tripod or even adjustable legs in that same sense, but here we are. 'Cause panning or tilting is not an option. So let's pull back, which is really where this guide is binding up. Find our focus. This would obviously be easier with the autofocus lens. I do have that other macro lens that would work for this, but we will make do. We'll get this as sharp as we can, which is difficult with all of the mechanical slop. And let's check the bottom. completely blown out by comparison, so we may just adjust as we do. Okay, we'll refocus again. Okay. Let's try to take our photo. Okay, now that should be processing. Let me blow my nose. Not sure how the mic is twisted. Alright, got you guys back. So now comes the dilemma. Do we just move the camera down? Oh, we can. I can slide the... just force the center column down. Okay. Let's get our focus again. Oh, I did that at the wrong... aperture. So we'll focus. Adjust our aperture. Take our photo. Okay, we've got a new photo of that one. It's being processed. Drop us down. We'll refocus, which I will adjust the aperture for. Now imagine all this 10 times more zoomed in, 10 times shallower depth of field. You would not be able to make any of this work with the amount of mechanical slop that there is. It just would not happen. Okay, so we've gotten that one. I may preview it just to make sure it wasn't super blurry. Actually looks quite decent. Okay, now we'll bring it down. This seems to be working so far. Okay. Oh, that was with the wrong aperture. Again. Trying that again. Okay. We'll drop it down. Open up the aperture. Punch in. It would be lovely if this was automatic. At least the photo stitching is. Okay. Adjusting aperture. Sliding down the camera. I'm going to see if the light can be moved. There. How are we doing this? Then... Okay, I think that's good. Taking our photos, processing. Yeah, it'd be curious if I could set this up on like a an Ender 3 gantry, like a Cartesian gantry. I have one that I don't use. To just lay something down on it, and then it would move a macro lens at the right height across. That actually might be pretty doable. You wouldn't need crazy precision, and you would have crazy precision with the height adjust, I think. So, okay. It's a good idea, cool idea. Have a proper macro rig and like a little lit space with a bunch of fill light. Be super dope. All right, I have no idea at this point if I'm doing these right. I'm just trying. But the brain, not quite processing like it should. Okay, so we've got that. And now we need to adjust our aperture back. Take photos. One more after this. And then we'll start looking at these results and hopefully they tell us something. All these, oh, I'll just do one more to be thorough. Turns into a lot of work on the back end, doesn't it? Okay, punch in. Manually rack this. Adjust aperture. Take photo. ISO's dropped significantly since we started. Okay, we're done back here. It's all processing now. So we'll come back over and swap mics. There we are. Okay, let's drop back into pictures. And I know we have one to delete in here. Let me see if Windows wants to load these in a sensible fashion. Nope. I get this photo and it starts me from the beginning. I don't understand it. Maybe, what if we made a new folder? Call it macros. And then brought all these into it. And now opened it. There we go. Okay. This one must have had the incorrect aperture. So now we can look at all this. And I can show you guys. Okay. So we left off with a pretty great result at, was it 22? We were noticing some interesting details in the beam along here. So let's carry on and compare. We'll probably look at the M's that are consistent. Okay. Let's look at the next photo. I did actually take individual photos this time of each. I tried to consider exposure and everything. This looks remarkably different. Like, just that much sharper. Let's see how 26 looks. Quite good again. Seems to be some validity to moving it each time. At least with how the lighting is. Though definitely on this same photo, 325 seems sharper than 326. '26 sharper than 27, thank goodness. 28, 29. So it seems 325 is our new king. If you had really precise alignment, which I could technically set up at some point if I really wanted to. Get out of here, Jan. Then you could go in fractions of a millimeter and work right around 324 to 326 and find perfection. Maybe it's a little bit closer to 324 instead of 326. Even just looking here, I would be inclined to agree with that. But we've changed our height by 5 millimeters. So I want to run this on paper and see what 325 looks like. So I'll try to line this up as precisely as I can. Which that seems to have done it. I'll set my weights off here. Let's get you guys a view again. Very good. My 2 dots are actually out of focus. My focus assist dots that I had been relying on when I first set up this laser and got it all rolling. Now we'll go back to the software and we'll run the test, the full test. And I'll just change our text to the appropriate 325. And let's just run it. Forgot my 1 layer. So now we've got all that. Interesting. So on paper, now why would that be? So my result is very faint, to the point you can't even see it. So is there a difference when we're using the marker where the marker can be removed easier than other materials? So then it's somehow using like the middle of the dot to affect things instead of the whole dot. But technically there's less power, it's just sharper. Because I could get a result if I drop my speeds by more than half. Definitely a result. looks incredibly crisp. I think that's what we're doing. I think we're using... Oh, that's what it did. I copied over something. Copied over the fill. Let me run this again. Alright, I ran it 3 times. Hopefully it's all in focus. And it's hardly even touching the paper. It's that top one. It's that top one. Do I have the right... You can't even see it. Very, very, very faintly there. It looks very sharp. On here, but I do know I can't see it properly there. So I guess this brings us to the original test that I did. And we'll just run this the way that should have been. So I think we could maybe make something here that would seem a little more continuous, not like the side-to-side lines. So let me bring up my screen, and we'll just hide these layers for now. I'll grab a new layer, and we will drop ourselves an ellipse, which I would like to be on a new layer entirely. We'll drop the ellipse in the middle here. Seems as though I've moved my layer. So we're gonna go back. Ah, okay, that's fine. We've moved layers. So we have an ellipse, and I can do an offset here. Offset shapes. I can tell it a specific amount. Why don't we do 0.15 millimeters? And hit OK. Is that fair? That seems incredibly close. Let's do that and redo that. Okay, undo it. Go back to tools. Alt O. So 0.1 is maybe not enough. Let's look at 0.5. Okay. I think I like this shape. We'll go to shape properties. I am going to type in symmetrical shape and set locked. And now we'll Alt O it. Tell it to offset outward. Point 0.3, 0.2, 0.1. Say 0.2 millimeters. And we'll now select that one, and we'll offset again, same amount, select that one, offset. There should be an array function to be able to do this, but right at the moment, this is working okay. So this is our other way of testing focus. We found what honestly is incredible, and I had no idea, where we've literally looked at the physical line clarity, and we have found that that does not match what we had originally had by almost 5 millimeters. So let me get rid of all these other lines, and now we just have concentric circles. And if I run this now, you saw just a bunch of circles get drawn, and it's absolutely gorgeous, really. It looks like a vinyl record in its anisotropic effect. I don't know. Let me see if I can show the effect on camera. Yeah, as I roll around, it reflects light differently. So yeah, very cool. I could, continue doing this. Let me actually just see if I could. That would actually kind of be dope. So let me pick this outer one. I'll hit array, and yeah, there's no way of adjusting sizing. So why don't, I think it's so cool. I think it's worth continuing here. So we'll just add several more. Maybe try to double it. Cancel that. Somehow selected the wrong thing. There is probably a way of doing this automatically, but right now, for the moment, this is the brute force method that will get me through. Okay, so now we have a larger record. And what that does is it buys me time. It looks like I have officially gone through my laser and marked my bed. Sad day. It was going to happen, though. Okay. I have another sheet that we can lay in there. It's flat-ish. Not very flat at all. Somewhat flat. Okay, so that's why we have that effect, is the light is actually passing through. You can see. So I have marked my base. Sad day. It was bound to happen. I wonder why, though. Why would it do that so much more? It is probably because we're running at 1/10 of the speed. That would be why, because our settings are different. Of course, also cube pulse width and everything like that. So let me grab my original settings from a different layer, add that in here. And we will actually drop the speed back, but we need to drop our effective power. So to do that, we need to decrease the pulse width down to 100 nanoseconds. And I will leave the frequency, we may even increase the frequency to its max of 40 kilohertz. We'll hit OK, lay our paper back in there, and see if it goes through again. Those settings should effectively reduce its effectiveness. Good. That has worked, so I can go even slower. Let's go 40 millimeters a second. Run that and make sure we aren't punching through. I think we're doing okay. I'm going to turn my fan on, not because it's actually venting outside, but it is just going to pull it to a different part of the room. Okay, now all we've done essentially is we've made a test that can run the beam for a long amount of time in a pretty localized area. I guess You could dive into the settings and you could set your idle beam to a higher setting, but that's a little bit scary because you could reach your hand across or something like that. Probably don't want to do that. So I've just set up concentric circles. If you had a spiral, anything that's going to keep the beam on, not move it too much for as long as possible. So we did that by a bunch of concentric circles, and then we decreased the power so we could really lower our speed so the beam can run for longer. What I'm also going to do that you could just do from the beginning is I'm going to increase the number of passes to 6. And now this is our third method. Take your headphones off because you're wearing headphones when you run a laser. And we will run this laser and we will adjust the focus live as we move it. Careful to not get our hands in anything. And we will stop where we will basically try to find where the laser is making the most noise. So we will adjust it up and down, and you'll be able to hear it go into focus and out of focus based on how much noise it's making, how much effect it's having on your material. If this doesn't work, we may need to increase the power so that we can actually hear it a little bit better. But let me give you the full view here. And we might even zoom in a little bit. So this should give you a view. I'm not worried now about our focus, like our starting point, because we are going to be adjusting it continuously. We're going to stop where it is focused. Let me do a quick test just to make sure we're not punching through, which we aren't. And I'm going to take all this crap out of the way, and we'll just hold on to this old manual style. So I'll run 5 iterations here, and we shall begin. So I think that's working, but I can't tell very precisely that it is. So I'm going to increase power by lengthening our pulse width. Might even go 300. And we'll start this again. Go. Put a little more venting. again. Well, that's awfully hard to hear. I know you can't hear it. That's for sure. But what I could kind of tell on how deep the marking was, or how evident the marking was, versus what I could barely hear, I found a spot that I think works. So why don't I measure that and we'll compare. And that is 319 to 320. Interesting. So on this test, where we make these spirals that we've made, which kind of look cool on their own, little manual lasering. What told me just by audio, what I could tell, what I could hear, see, kind of pick up on, is that 320 was our most effective. And I'm going to cover the beam and shut the laser off so I can take these glasses off, because I'm puzzled. Okay, that's our 5x. Where's our 10? There's our 10. What is interesting is that these are actually quite deep markings. So I think they were going to be difficult to tell. Yeah, there's just too much power. I think all I was achieving was burning deeper and deeper. So let's cancel this on the paper. There's just too much power here. So we'll grab our aluminum. We'll do some tests on the back of this and try to find a suitable setting. So essentially we'll be trying to locate something that affects the material here. And I think to do this most effectively, we will drop our frequency significantly. We'll go about half to 20 kilohertz. We'll increase our Q pulse to 1,000. And we'll keep the speed the same. And I will run this. Which we're going to turn that off because I left the beam on, or the cover. Our laser is heated up. Run this again. And you can see it's having an effect. Turn my fan on. It's actually really beautiful. this would really be the time to have proper ventilation. You don't know what kind of particles these are. Every single time what it's going to be off-gassing, we'll call it. So yeah, we got partway through on that test. This actually has a texture. It has actually affected. It's really pretty. Beautiful. Okay, let's rock this. Go for gold here. Turn that back off. Headphones off. Let me try to bring the mic over. You're obviously going to hear a lot more of everything. But hopefully also this test. I may adjust exposure here temporarily. Give you guys a better view. And we're just going to run this and perform the same thing. We're going to manually adjust the focus as we listen to this. Very cool. Let's point the mic away from that. So looking at this, it's very, very pretty. Wow. Okay. Adjust exposure back up. And I ended somewhere that seemed to be pretty effective. Maybe not the most, but I'm very curious to see what this measures to. That measured to, drum roll please, 321. So, hey Nomad, welcome in. So it seems like the 320, 321 range is the most effective on materials, but what we were seeing from the photos that we were looking at seemed as though almost 2 to 3 millimeters above that had the sharpest beam. And all I can really assume is that the middle of the beam is laying down, let's say, and not the full beam. Because we can look at even 323 compared to 325. Is visibly different, but especially 325 compared all the way back to 3. We should actually probably look at 320. All the way back to 320. 320 has these very large, full-sized beams. So that's kind of fascinating. Definitely worth knowing. I think what we can write down, at least for myself, on a scrap piece is those numbers. So I'll write that we got 3. This is on the 150 millimeter lens. We got 320 millimeters for, we'll call it depth. And 325 for mark. Sharpness, I guess. Almost wrote on my mouse pad there. So with that written down, I guess I could also, I might as well, laser etch this. So let's mock this up real quick. We'll go back to the program, bring up our side view. I'll go ahead and set my camera back to a secondary point, and we'll hop back in Lightburn real quick. And let me just grab, ideally, an entirely new layer. And we'll lay down some text. This will be the 150 millimeter lens. Oops. And we'll just bring our, I think actually 5 mil is probably too tall. Let's look at 3 mil tall text. I think that's reasonable. And now I'll select that layer and drop it onto a different layer. I'll hide the other one, but I am going to copy the settings to move over there. But we're going to make it a fill. So we have 150 millimeter lens. We'll go back to text. And we'll just say 320 for, we'll call it cut. And 325 for sharp mark. Just so I have something to work with in the future. And then I'll align these left. 325 millimeters. And debating if I want to format this any differently, but I think it could work still. So what I have over here, I think this is focused for the aluminum still, so I'll just, yeah, 320. So we'll bring this over. And I think that's pretty centered. We will run this just one pass for now. And I'll put the interval quite a ways down. We'll go 0.6. But we'll keep these other settings. And I'll just... give you guys a view here. Zoom in a bit. Pan over. I'll adjust exposure. If we had the vent going, I would probably, like actually venting outside, I would probably try to cut this out. Just to test it. But in this case, we're just trying to mark. So let's hit it. Makes a lot more noise than the paper. It's very bright. So this was one pass with all those fill settings. It looks glorious. I kind of wish I had put it up more in the corner so that I could cut it out. So I think I'll do that. Skew this near the corner and just hope I don't do anything. And I'll run this again. So gorgeous. It'd be incredible to get a macro shot of this being done. I wonder if I'd trust putting one of my cameras that close. That much energy going into metal. I have some nice shears on my desk. So I will just cut this corner out. Go. Now that'll never lay flat again. And then I'll just square off this cut so it's more of a badge. If I was a braver man, I'd probably try to add a contrasting color inside the letters. But I've moved a little bit farther past that for what I want to do, but hopefully you can see this. There you go. Now I could put this up on top. I can actually just lay it there for now, but I could glue it. And now I know that at the end of the day, I need to have 150 millimeters lens. The 150 mil lens needs to be at about a 320 mil cut depth, and for some reason 325 for a sharp mark. So we've got some numbers to play with now, and this can be permanently or semi-permanently fixed on there. Maybe a little bit of glue stick. Let's try that. Say, I wish I could have sworn I had like 80 glue sticks. This is the purple stuff. So is this, okay. Okay. Wonder how long I have to hold this. Or if it even stays. I doubt it glues aluminum. I've got a backup idea. Nah. Nope. It will not. This is just blue tack. It's that, I don't know what you want to call it, the tacky stuff you can put pictures up on walls with without it damaging the wall. I feel like I have to get this glue stick off. Just add a little lump to one end. Add a little lump to the other. Bend it straighter. Squish it on there. I think our paper's in the way. That's what it was. Can also increase exposure a touch. There we are. Actually looks kind of good. Sticking out a little bit. 3D. Yeah, when I get the 70mm lens installed, turn this bad boy off. And that bad boy. When I eventually get the 70mm lens installed, we will be able to set a separate one right next to that. And my goodness, it's good to get these goggles off. Whew. Yeah, that's a decent bit. We got some good results. So we tested 3 different types of focusing. We actually we want position 2. Oh well. There we go. There you go. Good grief. All right, so yeah, we found that the line test, where you would look at the actual distance of the lines, is simply not effective here. It is, the lines are too fine to be able to tell that easily on paper. So then we looked at the gaps between interval layers. Our beam is known to be smaller than 0.1 millimeters, and we had a 0.1 millimeter interval. So if one distance was not showing gaps and another was, then we knew the one that was showing gaps was sharper. But we also found that it seemed like you could move the laser even higher and it would almost sample the middle of the laser. But it was much less effective. It would not cut as much. So that's kind of curious, something to explore later. But now we have our official markings that we can reference at any point because it's on the laser itself. We also tested the method where you kind of keep your laser interacting with the material and you adjust focus as you're doing that, and you just listen for the sharpest moment. That didn't work so well for the paper because it just obliterated the paper really quickly, so we moved to the aluminum. But it's hard to hear it over the fan, and we just really do want ventilation on metals and stuff like that. Another way that you can do this is prop up a material so it's at an angle, and then run something along that height change, and you'll be able to ideally see where your line gets the thinnest or where it starts to dig in the most. In this case, it would be really hard to reference that same distance. So maybe you could instead have a material with shims under it of specific lengths and remove like a 1 millimeter shim each time. Maybe that would be easier for you. So there's a variety of ways that you can accomplish this, and we tested out 2 to 3, but we got some really good photographic evidence of some of these results, which is fun to see. But we have what works, and we have another measurement to experiment with in the future, and I think that's a really, really good result. So I'm really happy with that. I have stayed up later than intended, which happens, but I think we're gonna just leave it there. We did, on my agenda sheet, get through the unboxing for the dumbbell, and we did tethered macro. It's as far as we got, but that's still really exciting. I think there's a lot to come from the macro setup and the different things that we could do with that in the future, with focus stacking or image compositing. I think that will be all very interesting and very exciting. Let me pop through my lurks right quickly. We got some Canadians that are still awake. I think we will raid into Belize too. Yasmin, are you up early? I'm hoping, and you haven't stayed up super late. Yeah, I hope you went to bed at a reasonable time and you're not up late like me. But yeah, we finished up with the laser. We were doing some kind of interesting, semi-intricate. Get this just right. You can kind of see the swirly pattern there. Yeah. Complete the 5th. Uh-oh. Oh no, yes. But what we were testing, if I zoom way into my face here, is the focus setting on this here laser, because I forgot what it was. I set it up, I calibrated it for 320 millimeters from that line, but we went through and we tested it and we discovered something that was really interesting. I'll show you this as well, because we still have it all pulled up. So under my photos here, we set up a macro rig in the background, which I should be able to zoom in as well. Being very lazy right now. Panning, zooming. Yeah, so that's camera. We had this set up with a macro lens that we would, we were just taking macro shots is what we were doing. But we also used a feature on there, on this particular camera, where it can sample, it moves the sensor and it samples in multiple places, so you get kind of an increased resolution, which is super cool. But yeah, we looked at these photos, which I've been wearing goggles for the last 4 hours, so this is really nice to see with naked eyeballs. But yeah, this is the enhance. This is the distance from the material to the reference line that we saw on the laser a minute ago. And our closest at 317, you can see it's just not as crisp. And as the line gets sharper, you start to see the space between the lines. A very, very expensive and fancy laser pointer, yes. So as we increase in height, it actually seems to get crisper and crisper. And what we discovered, I don't think that was it. Let me bring up my photos again. Windows has been really weird this evening with photos. And I hate it because it just breaks the vibe. Where's my macros? There we go. So we're finding over here, as we kept increasing distance, we kept getting these gaps to be larger and larger, to the point that 325 seemed to have these really precise lines, and it was like almost each individual pulse is almost visible now, which is really fascinating. But we also discovered that when we went back and tested this on paper, it was hardly marking the paper. So this is less powerful, yet somehow more detailed. 5 millimeters of difference on the focus height. So yeah, now I've labeled this forevermore on switch, scene switch. There we go. Da-da! Right there. Post this in Gonad's Discord. Yeah. Yeah, that'll get me on there. Just that we did some stuff. I think it's actually sampling the very middle of the laser. Like, laser light, the way it's generated, it isn't necessarily... I mean, it's focused light at the end of the day, so it's not going to be a perfect amount of energy all the way through. There can be a center area that's stronger, and I think that's what's happening, is we can have lower power, but much sharper, because we're just using the middle if we move up. So I'm really excited to play with that in the future, because this lens is like twice the dot size, I think, as its even sharper one. And this is already to the point where when I use a 10x loop to look really close at a material, paper can't resolve the resolution of these lines. So I had to use aluminum sheet with marker over it, and then remove the marker because the aluminum is finer texture. And I can't tell with my naked eye, so I had to literally use a macro
camera set up to get that to work. Also, I got some dumbbells, adjustable dumbbells, and an adjustable kettlebell. And they're super cool. I'll demo for you briefly.
Switch microphones and go wireless here. But yeah, these are really cool. They're like a knockoff of the cheap brand, or I guess that brand's not cheap, but the way they work is super simple. You just thread out the bolt a little bit, and then these plates come out. And you can adjust. This is 80 pounds on this one. You can get longer screws and you can fit double this. You could have 160 pounds per, I believe. I'm not that strong, but these plates come off and then they can mount on this, this kettlebell, just the same way. And then they have barbells, they have different things, but you're spending your money on the plates and then you can reuse it elsewhere for other tools. Yeah, you notice that too. Just the dumbbell sitting in the background. But yeah, I think that's it for me. I'm gonna raid out my little raid of 2 back to Bleezy, and I've got a clip to drop on. Oh, hey Dana, would you mind raiding through to Bleezy for, let me put a camera on my face. Sorry, I got excited. Fantastic, and then if you wouldn't mind hanging out there for a few minutes, that'd be excellent. I'd be so thrilled. And then go to bed. And go to bed right after. But give it a few minutes. Should be there anyways. Yeah, fair enough. But now you get the little raid square box of yellow. Okay. My view is absolutely tiny here, but we're gonna hit the raid. Go to my following list. We've got Bleezy. Okay, thank you all for joining me on these adventures this evening. We took a look at a set of adjustable dumbbells. We messed around with the laser. We got some proper laser focus, and we made a new discovery that might enable even sharper resolutions. But we are gonna raid out to Bleezy. He is playing Rocket League. Let me hit some buttons, make some things happen. And in about 5 seconds, we'll be on our way. Thank you all so much for watching, and I will catch you guys later.